Hey guys, my live classes this morning were going in and out, and so I wanted to make a recording just in case class crashes so that you had just a couple problems to look back at. So you should have already done lesson 1.01 and 1.02, but I just wanted to do a couple questions just to make sure that you feel confident. So if you were kind of struggling a little bit with the segment addition and angle addition postulate, watch these next two examples and I hope that it's going to help you a little bit. So first of all, just to make sure that we understand the segment addition postulate, let me just take a snip of this. If you have any line segment, like let's just say that this is our line segment, and let's just say that this distance is 4, and the total distance is 10, we can always figure out the other missing piece because these two sides have to add up to the total. That's what the segment addition postulate says. It says this piece plus this piece has to equal the whole thing. So since this is 4 and the total is 10, we could do 10 minus 4, and we would find out that this piece is 6. Or you could say it the opposite way. You could say 4 plus 6 equals 10, or 4 plus what equals 10. So the segment addition postulate just says that you can add the two pieces together and set it equal to the total. So that's what we're going to do, but in some of these problems it requires a lot of algebra, which is why I wanted to go over some that had a lot of algebra in it. So this one says point D is on the segment BC, which we can see it right there. Segment BC, so from B all the way to C, whoa, that was a funny one, measures 8x. So that whole entire distance is 8x. That's the total. We want to figure out what the length of BC is. So we want to know, we don't want it in terms of x, we want it as a number. So we're going to use the segment addition postulate. We're going to say that this piece plus this piece is going to equal the total, which is 8x. So we're going to set up that equation and we're going to solve it. I like to draw lines down my equal sign just to kind of keep it straight. And that reminds me, whatever I do to one side of the equation, I have to do to the other. But first I'm going to combine like terms. I have 3x's plus 4x's, so I have 7x's on this side. And then I have 8 numbers plus 10 more numbers, so that's going to be 18 numbers. And then I'm just going to bring this straight down. All right, now I notice that I have x's on this side and x's on that side. I want to combine those. I want to get them all to the same side. But anytime I go over the equals line, I have to use opposite operations or inverse operations. So I'm going to go ahead and move the 7x over to this side. But when I do that, I have to do the opposite. Right now it's a positive 7x. So if I want to move it over, I have to subtract 7x's from each side. And if I subtract 7x from this side, I have to subtract 7x from this side. 7x's minus 7x's cancels. That's why we do that. I can bring the 18 straight down. And 8x's minus 7x's would give me 1x. And it doesn't matter if you put the 1 there or not. You can just write an x or you can put a 1x. And then I want to solve for x, and this already says that 1x equals 18, but if you just felt like dividing by 1, you can do that. It's not going to change it. X is going to equal 18. So x equals 18, but be really careful. This question doesn't say solve for x. It says what is the length of BC. So it would be terrible to do all this awesome algebra and get down to x equals 18 and type that in as your quiz answer, because 18 is not the answer. It wants to know the length of BC. And BC, let me see if I can change colors here. BC is 8x. So to get the length, we would plug in our value of x, which was 18. And then we would just calculate that out. I don't know that off the top of my head, so I'm going to type it in my calculator. 8 times 18 is 144. So BC is 144 units long. All right, so that's one example of the segment addition. Now let's look at an example of the angle addition postulate. So let me get a new picture here. All right. So it says the measure of angle RST, and whenever you're looking at angles, you trace it out. So we start at point R, we trace to S, and then we trace to T. So this big red angle here is represented by the expression 6x plus 12. So this whole angle here is 6x plus 12. And we want to find, let me see if I can change to a highlighter, we want to find the measure of angle RST. So again, that's this big angle. We want to find the measure of it. This little m here stands for measure. So we don't want to know that it's 6x plus 12. I don't want to know that. I want to know what the actual measure is. So we're going to use the angle addition postulate. We know that this angle, RSU, is 78. And we know that this angle, UST, is 3x minus 12. So we can add those two angles together. We can say 78 plus 3x minus 12 has to equal the total angle. So we took this piece plus this piece has to equal the total, which is 6x plus 12. And then we're going to draw our line down our equal sign, and we are going to solve. So I like to combine like terms on one side first. So I notice on this side I have 78 numbers minus 12 numbers. So I would go ahead and combine those, and I would do 78 minus 12. And then I would just bring the rest right down because I don't see anything else that I can combine. So I'm going to bring the 3x down, and the 6x, and the 12. Now I notice that I have x's on both sides, and I want all those x's to be on one side. I don't want them to be on different sides. Doesn't matter which way you move them. If you always like your x's to end up over here, that's fine. If you always want your x's to end up positive, you can do it that way. It just doesn't matter. I'm going to go ahead and make my x's end up over here, which means I need to move 6x. And anytime I want to move it across, I need to do inverse operations. So since it's a positive 6x, I'm going to subtract 6x from each side. Whatever you do to one side, you have to do to the other. 6x's take away 6x's would cancel. So I'll just bring this 12 straight down. 3x take away 6x is going to leave us with negative 3x's. And I'm going to bring the 66 straight down. Now all my x's are over on this side, which means I need my numbers on the other side. So now I need to get rid of or move positive 66. So to get rid of it, I would subtract 66. But whatever I do to this side, I have to do to the other side. 66 take away 66 cancels out. I'm going to bring this negative 3x straight down. And 12 minus 66 is going to give me a negative 54. And y'all, please use your calculators. I use mine all the time. So don't be embarrassed. Use it. Okay, so from here, now I have negative 3x, and I want to get just the x by itself. And I'm not going to add 3 to each side. That's tricky for a lot of people, but it doesn't say that I'm adding the negative 3 and the x. Right now I have negative 3 times x. Anytime they're pushed together, you are multiplying. So since I'm multiplying x times negative 3, the opposite of multiplying is to divide. So I would divide each side by negative 3, because a negative 3 divided by negative 3 gives me just a 1. So that would leave me with 1x. And then a negative 54 divided by negative 3 would give me a positive 18. So I solved for x, and I got that x equals 18. But that is not what the question asked for. The question did not say solve for x. The question says, what is the measure of angle RST? So now we're going to go back. We know RST is represented by 6x plus 12. So now we're going to plug that 18 in for x. And this just becomes calculator work, so multiply it out in your calculator. 6 times 18 plus 12 is 120 degrees. So the measure of angle RST equals 120 degrees. All right, I hope that helps. So I hope those two examples helped with the segment addition and angle addition postulate. I also wanted to talk about proofs today in class, but this is something that I really want to do live because I want to get your feedback. So I'm not going to put this on the recording, but what I will say, and what I will do is I want to share this video with you.
What is proof, and why is it so important in mathematics? Proofs provide a solid foundation for mathematicians, logicians, statisticians, economists, architects, engineers, and many others to build their theories on. And they're just
All right, so we are going to talk about proofs more in live class, but one of the first things that you have to be able to do to write any proof is you need to know the postulates, theorems, and definitions. So I'm going to attach in the email with this video some things that you're going to need to know. So make sure you save those files and use them as a reference. I will see you guys in class Friday.